Here we observe Nicholas in his natural habitat, doing something stupid. Well done, Nicholas. It appears as though you have injured yourself. Nicholas has brain imperfections. However, this is natural and cannot be remedied. His other injury, however, is curable. Now, while this may just look like a nasty cut to you and I, deeper within, a massive battle is about to transpire.
Children, gather around. Observe the glorious open flesh and the oozing red liquid. Today, we feast.
Halt! You think you can pass right by me?
I can.
The macrophages engulf the unfortunate pathogen through endocytosis. Soon, the cell's lysosome will fuse with the vacuole containing the pathogen, and she will die through phagocytosis. Poor little pathogen. Her friend, however, runs on into what he thinks is a safe zone. Little does he know, he is entering no man's land itself, and there are many more dangers that await him.
Here come the neutrophils from the capillaries. They're going to phagocytize the pathogen and use endocytosis to break him down.
The macrophages and neutrophils release cytokines to attract more phagocytic cells from the blood. This increase in phagocytic cells, white blood cells, cell debris, and dead pathogens results in pus oozing from the site of injury. Next, we have natural killer cells. They detect pathogens based on detection of surface proteins and other materials typical of pathogens through toll-like receptors. Membrane molecules that trigger this toll-like receptor include lipoproteins, double-stranded RNA, flagellin, and unmethylated CG. Once they recognize a pathogen, they then release chemicals that lead to cell death.
Next, let's move on to the adaptive immune response. Within the bone marrow and the thymus, the infamously intense drill sergeant welcomes new recruits, B and T cells. The maturing lymphocytes must never drop their guard, for soon they will be tested in the bone marrow and the thymus. If the young lymphocytes develop any receptors for the epitopes on Nicholas's body cells, they will be terminated via apoptosis. But, for some, the temptation is just too great.
Welcome to boot camp. Here we are going to put you through the most extreme physical pain you have ever experienced, and you'll become the best pathogen fighting unit in the force. What is your name, Private?
Mr. T.
You will start and end every sentence you'll start. Now drop and give me 20. Push her to nincompoop. And what did your pathetic parents name you?
Sir, Mr. B, sir.
You're a very strange-looking individual, sir.
Sir, that is true. My parents have me tested. I'm indeed a strange-looking individual, sir.
Which one are you going to attack, Private? Yes, sir. And you, which one?
That one.
Yes.
Yes.
Go. And you, which one are you going to attack? Do an about face to left face and get out of my face. Send that one to the apoptosis room.
Will do. And then the cells graduate. They go on to circulate the body, each one with an antigen receptor for a specific antigen. If they should come across an antigen that contains an epitope that tickles their fancy and detaches, then the cells will activate.
Let's start off with describing the postgrad of T cells. We open our scene with a macrophage. It has just eaten a pathogen and is currently breaking down its antigens. With the help of MHC Class II, the macrophage will present an antigen fragment on its surface for an inactive helper T cell to find. The helper T cell, upon contact with the antigen fragment, is activated. Then the accessory protein, CD4, latches onto the attachment site, keeping the helper T cell from drifting away until the cytokines stimulate the cell to divide and differentiate. All of this starts with a simple detection on the receptor of an infected cell.
Good afternoon, Doctor.
Good day, body cell. Our dear boy Nicholas has encountered another freak streak of stupidity. My office has been very busy. Now, how may I help you today?
Well, you see, Doc, I've been ingesting some antigens lately, and I'm not feeling that well.
This antigen fragment is of my expertise. Darling, I'll get right to the point. The only solution for you is cytotoxic T-cell perforin granzyme treatment. Perforin will form pores in your plasma membrane, and the granzymes will take care of your proteins.
What do you mean, take care of my proteins?
Well, a cytotoxic T cell specific to your antigen will bind and release porphyrin and granzyme to lyse you. This process is commonly known as apoptosis. Now, if you'll excuse me, this is helper T cells. Send out the cytokines. We need B cells and cytotoxic T cells. Do you read? We need B cells and cytotoxic T cells.
After the attachment of the helper T cell to the MHC Class II, cytokines are released again to signal the activation of cytotoxic T cells and B cells. The activation of B and T cells results in the proliferation of many copies of these cells that are specific to the received antigen. This is known as clonal expansion. The increase in the number of lymphocytes specific to the pathogen is a positive feedback mechanism that greatly increases the rate at which lymphocytes can act on that pathogen.
Hi, I'm the activated T cell. That is an infected cell.
My cytokine senses are activating. Never fear, Mr. B is here. Aha! Now back to the helper T cells. If I can find one with a receptor for this bugger's antigens, then I'll be able to proliferate and differentiate into plasma cells and memory cells.
But Mr. B, what on earth can those do?
Well, helper T cell, I'm so glad that you asked.
My plasma cells will secrete antibodies that will have an antigen receptor for this here antigen. They'll attach to more pathogens and make them look delicious to macrophages and neutrophils. This is known as humoral response. The memory cells will keep our posterity in good hands. Should Nicholas ever be exposed to this type of antigen again, we'll be ready to respond faster and nip it in the bud within a short while.
Wow, thanks, B-Cell. I can always count on you.
But you can do it too.
What?
You see, you too will differentiate into memory helper T cells as well as memory cytotoxic T cells specific to the antigen that we have just encountered for the first time. These memory cells last for decades, prompting a much faster acting secondary response to this pathogen, should we ever encounter it again.
Well, it appears as though Nicholas's body has managed to fend off the deadly invasion. I hope you have enjoyed your time with us in viewing the magnificence of the body and its mechanisms to compensate for astounding stupidity. Good day, and stay classy.
What is your name, Private?
Mr. T, sir.
You'll start and end every sentence with sir. You
Sir,
did.
yes,
Don't say sir.
All right.
I didn't realize.
And what did your pathetic parents name you?
Sir, Mr. T, sir! Mr. B, You're Mr. T.
You're a very strange-looking individual, Private.
Sir, yes, sir. I am indeed a strange looking.